Alright, we are getting close to wrapping up this chapter. We've got three more sections to go through. This section here is to talk about theoretical and experimental probability, and then we've got a couple more things to look at. But other than that, this one here, again, is just theoretical experimental probability, which is the basic idea of probability. So make sure you get this today, because the next lesson you have after this is actually putting combinations of probabilities together. Actually, it's only two more lessons, because 12.7 is our last section. So we'll have a lesson today, a day to review everything tomorrow, along with a brief quiz, and then one more lesson Tuesday, and that'll set us up for the test. So hopefully you've been preparing yourself to kind of fight your way out of this grade that you have if you don't like where it is, and everything else should work out like it's supposed to. Other than that, it says you should have, or as it says, it should have some basic experience with probability at this point in your math careers. The formula is probability P, which is what P stands for. Event E is P of E. Probability of an event occurring is number of successes over the total. It is an easy process to understand, but again, it's the execution that causes people the most issues. Make sure you count the number of outcomes that are what we would call good divided by the total, and that will give you your probability. Our essential question is, because there are two different types, what is the difference between theoretical and experimental probability? Theoretical probability is probability that should happen. So in theory, since there is a head side and a tail side, there is a 50% chance that you flip heads on a coin. So theoretically, if you flip a coin 100 times, it should end up at 50 heads, 50 tails. But of course, in real life, we know that doesn't happen. It might end up at 40-60. It might, on occasion, end up 30-70 or 70-30. We really don't know, only because a coin is not, always weighted the way it's supposed to be. Plus, just life happens, so you really don't know if that's going to happen. So theoretical probability, again, is what should happen. Whereas, if you were to actually do an experiment and you wrote the results down, that would be your experimental probability. So the experimental probability can be decided based off of just doing the experiment and saying, hey, based off of the experiment that I did, this many heads actually occurred. And so the probability of, in this instance of us getting a heads, is not 50%, it's more like 30%, or it's more like 80%. So experimental probability, as you should be filling this out in your notes, is probability that actually happens, whereas theoretical is what should happen. Don't forget also that probability is a percentage. Probability of 0, I'm sorry, if the probability, this isn't written right, but a probability of 0 means that there is 0% chance of something occurring. This shouldn't be right here as a number, because that's really not what we're looking at. But if your probability was 0, that means there's a 0% chance. If your probability is 1, that means it's a 100% chance, because remember, if you turn 1 into a percentage, you actually add the zeros, giving yourself a 100%. So something with a probability of 0 is like rolling a one six-sided dice and getting a 7. Or a probability of 100% chance occurring is flipping a coin and getting heads or tails, because you're going to get one of those two. But like I said, I mean, it's just kind of hard to discuss right now on the video, but like I said, 100% means it's going to happen all the time. 0% means it's never going to happen. So if you consider this problem based on the experiment, we found there's a 33% chance of a light bulb burning out too early. If your company purchased 2,000 light bulbs, how many are expected to burn out early? Again, experiment here, this is your experimental probability of 33%, or as you might see, 0.33. Once you get that number, that means you can apply that number to your situation. So if there's a 33% chance on your experiment and you purchase 2,000 light bulbs, you would simply use, remember with percentages you usually multiply, you would do 0.33 times 2,000. And when you do that, that would tell you about what to expect. So 0.33 times 2,000 is 660. So it doesn't mean that exactly 660 bulbs are going to burn out. It means that based off of your sample, your set of light bulbs that you purchased, there's probably about 660 of them that aren't going to work as long as they're supposed to. Again, that is the experimental probability that we're talking about there. So some examples that we're looking at. At a school festival, colored chip is randomly drawn out of a bag and replaced. The table below shows results of 50 draws. Find the probability of choosing the blue chip. So again, probability is success over total. A success to us is choosing a blue chip. And so therefore you go to your blue. We have 9 of those, so there would be 9 good ones out of, should be 50, but let's just add to make sure. 11, 14, 9, 16, which is 50, so it's 9 out of 50. which you could turn into a decimal or you could leave as a fraction. Just depends on what they want. But 0.18 would be your probability of selecting a blue chip. So 18% chance that you select a blue chip. Another example, you roll a 12-sided die, find the probability of the number being greater than 8. The easiest thing to do here, if you don't know, again, as you can save time, is to write out all the possibilities and then circle the ones that are good. 12 is greater than 8, 11 is greater than 8, 10 is greater than 8, 9 is greater than 8. Is 8 greater than 8? It is not. So you don't include the 8, and again, that's why it helps to kind of write it out. Otherwise, you go 8, 9, 10, 11, 12, but write them out and you know that this doesn't belong. That means that there are 4 good numbers out of 12. And again, what you do there is 4 divided by 12, which is 0.33 as your probability of getting a number greater than 8. Alright. And then the last example, which is kind of long, but again, this is a question you're going to see on your assessment. It's kind of like an experimental probability with some more stuff that we need to discuss. It says your company builds 1,300 cars. Of that 1,300, 21 were found to be defective, which is actually pretty good. What is the probability that a random car is defective? So again, you want the probability first. And again, probability is success over total. And success doesn't mean a good thing, it means it's what you're looking for. If we want the car to be defective, success would be any car that's defective, and it says that 21 were found to be defective. The total number of cars out of that group is 1,300, and so you do 21 divided by 1,300, which is 0.016, which I'll go to the third letter or third number because that's good to do. So 0.016 is the probability that I end up with a defective car. The complement, go ahead and put this above the word complement. The word complement just means opposite. So to describe the opposite of this event, it means you could use the word not. So the complement would be not defective. If the probability was that you get a heads, then if the probability here was the heads, then the complement of that would be not heads. Complement just pretty much means put a not in front of it because you don't want that to happen. So if one is defective, then you want the other one to be not defective. If one of them is someone older than 20, then you would say not older than 20. That's pretty much how you find the complement. And the probability of the complement, if you think about the fact that everything should add up to 100%, you would just do 1 minus whatever your original percentage was, which is 0.016. That's one way to do it, and you would end up with 0.984. You could also do the mathematical way of the complement and say if 21 out of 1,300 were defective, and subtract that, that means that 1,279 were not defective, and you could use that 1,279 over 1,300 to get, again, the same answer, 0.984, I believe is what it was. Yep, and if you round that, that's what you get. So again, the complement is what you're looking at there. And then the last thing says if your company has to build 5,500 cars for an order, about how many will be defective. Again, based off of this experiment. In the experiment that we did, we made 1,300 cars, 21 were defective. That gave us a probability of 0.016. Again, that is a percentage even though it's in a decimal form. So what we do is we take the 0.016, which is our percentage, times the overall sample amount, which we're going to do, which is 5,500. And that should give us a number that we can say is error. So 0.016 times 5,500 gives me that 88 of those cars would be expected to be defective. So again, keep in mind, use today to get the general idea. Come back tomorrow and you have box and whisker plots. You have counting techniques, and you have this section to kind of practice before we take a brief quiz at the end of the hour. Just make sure you plan your time wisely because, again, if you do well on this quiz tomorrow, your grade will continue to increase and continue to increase until you get where you need to be. So other than that, go ahead and get started on your Math Excel, and again, ask whatever questions you need to. Good luck.